Find the nth term in the sequence. 2, 5, 8, 11, dot, dot, dot. Here these numbers alternate between odd and even, but there's something else that's in common with this problem. You start off at 2 and then it goes to 5, 8, and 11. Looking at this, the difference between each one of these is 3. So, based on that, we can come up with the following formula. AN is equal to 2 plus 3n, where n is equal to 0, just so that way we can get 2 plus 3 times 0, 2 for our first term in the sequence. 1, 2, 3, and so on and so forth. So a sequence doesn't necessarily have to start at 1. It can start at 0 as well. And notice, since we're always adding a multiple of 3, that's either going to switch from an even to an odd number. So that explains our first observation as well. Now for the second sequence, 1 minus 3 halves, positive 9 fourths, minus 27 eighths. We have an alternating sequence, so it's AN is equal to negative 1 to the n. And I don't know if this is going to be n or n minus 1, just depending on how the fractions. What I'd recommend is let's try to figure out these fractions first and see where we're going to start our sequence at 0 or 1, and we can adjust it then. So the first thing to note is that we can make this 1 to 1 over 1, and the numerators go from 1 to 3 to 9, 27. So those are clearly powers of 3. So this is going to be 3 to the n. And then the denominator, 1, 2, 4, 8, those are powers of 2, so that's 2 to the n. Now, let's see where we should start this off. 1 and 1, so it looks like that would be n to the 0. So if we start our sequence off with 0, like our last sequence, 1, 2, 3, dot, dot, dot. Now, let's just make sure that that works out with a negative 1. So if we did that, negative 1 to the n, starting off with 0, that would mean our first term is positive 1, or positive. Yeah, and that does correspond, so that is correct. So that's our answer here. I do want to add one further comment, which is you may have had a slightly different answer. You could, for example, have said AN, this is for A, this is just an alternative. AN is equal to 2 plus 3 times n minus 1. Now, the reason why you would be allowed to do that is, well, since you really reduced the formula in my solution by 1, you would have to then increase the n in your what they call index by 1. So there you would start your formula with n equals 1, 2, 3, dot, dot, dot. And notice that would give you the same answer, because the first term would be a1 equals 2 plus 3 times 0, which is just 2. So you might have very well come up with this for an answer, which is fine. And for B, it would be AN equals negative 1 to the n minus 1, 3 to the n minus 1, 2 to the n minus 1. Again, just kind of articulating the idea that we're reducing all of these by 1, and to balance, you would increase this by 1. So then you would start with n equals 1, 2, 3. So if you had that answer for B, then that would be perfectly acceptable also.